electrochemical series or activity series. We have a, a set of species which have been arranged in a particular order, whether increasing or decreasing order of electrode potential. If we say electrode potential, what you will understand? If I say just electrode potential, then what you will understand? Whether it is reduction potential I am talking about, or a oxidation potential. If I say electrode potential, always and always consider it to be reduction potential. Consider it to be reduction potential. Simple. I should mention reduction or oxidation. If I am not mentioning, if only I am talking about electrode potential, then I am talking about reduction potential. Alright. And if I am saying standard electrode potential, that means standard reduction potential I am talking about. So, arrangement of a species on increasing order or decreasing order of standard reduction potential or standard electrode potential is known as, that arrangement is known as electrochemical series or activity series. We have few species out here which have been arranged in decreasing order of electrode potential or standard reduction potential, standard electrode potential or standard reduction potential. So, what is the use of this? This has multiple uses. Firstly, you can understand that reducing reducing power reducing power or or reducing agent character, reducing power or reducing agent character, it is inversely proportional to standard reduction potential or electrode potential. SRP is nothing but, this means standard reduction potential. Standard reduction potential. This is also called as standard electrode potential. Same, standard electrode potential and standard reduction potential is same. Alright, standard electrode potential or standard reduction potential, one and the same thing. So, reducing power is inversely proportional to electrode potential or SRP. Similarly, oxidizing power of a species or oxidizing agent nature or oxidizing agent nature. This is directly proportional to electrode potential or standard reduction potential. Oxidizing power directly proportional to electrode potential or standard reduction potential, and reducing power inversely. So, what do we have out here? We have decreasing value of standard potential. That means fluorine is at the top. So, fluorine has highest reduction potential or electrode potential. So, fluorine is directly is oxidizing power. So, fluorine is the best oxidizing agent we have. Fluorine is best oxidizing agent because it has the highest electrode potential and oxidizing power directly proportional to SRP. Now, lithium is at the bottom. That means it has the lowest reduction potential. That means it is the weakest or poorest oxidizing agent. So, if it is weakest oxidizing agent, poorest oxidizing agent, lithium, then lithium is best reducing agent. So, fluorine is best oxidizing agent and lithium is best reducing agent. Best oxidizing agent at the top, best reducing agent at the bottom. And from this you can understand, down if we go from top to bottom, then oxidizing agent character or oxidizing power is decreasing and reducing agent character and reducing power is increasing. So, this is a beautiful thing which we can understand from this series. So, you can understand how important, how critical this could be. When you want to understand which is a better reducing agent, just check out which one has lower electrode potential. Lower electrode potential means better reducing agent. Higher electrode potential means poor reducing agent or better oxidizing agent. Alright, so this is how beautiful this series is. This helps us in making out so many decisions. Here we have arranged to predict reducing and oxidizing agent character. What I explained to you, lower the electrode potential, reducing better the reducing agent, already explained. Next is higher the electrode potential is stronger is reducing agent, already explained. Next, you can predict from which of the following can remove hydrogen in form of a gas from a mineral acid. So if electrode potential of a metal is lesser than hydrogen, most of the metals have lesser oxidation potential than hydrogen, so they can remove hydrogen of mineral acids, or for that matter they can reduce hydrogen from H plus to H2. So better reducing agents such as magnesium, aluminum, zinc, iron, all these have negative oxidation potentials and hydrogen has a potential of 0. So negative oxidation potential, less oxidation potential means better reducing agents. So they can remove hydrogen from mineral acids, replace them, right? And copper, silver, mercury and gold, they have positive reduction potential values, electrode potential, so they cannot replace hydrogen from mineral acids. So these are few beautiful things we can just predict by knowing the values of reduction potential. Alright, next what do we have? In going from top to bottom, you can understand most electronegative fluorine is at the top. So electronegative elements are at the top and electropositive elements are towards the bottom, right? Next is moderate electropositive, weak electropositive. You can predict easily by knowing the values of electrode potentials. So electrochemical series or activity series helps us in making so many decisions. For example, if you have a copper rod and a zinc rod and you dip them in the solution of their ions, and you have to make a decision which much should be a cathode and which much should be anode. So then what is the procedure? You will check which metal has higher electrode potential. The metal having higher electrode potential will form cathode and metal having lower oxidation potential will form anode. So copper has higher electrode potential, so copper is taken as cathode, and zinc has lower electrode potential, so we take zinc as anode. So there are multiple uses of electrochemical series which you will be getting to understand in this video, and further we will be talking on more applications of this electrochemical series as we move ahead. Thank you so much.